JB from Anatech Corporation here today. We're going to talk about some of the more sophisticated and useful things that you can do with your DCA75. Very handy gadget. Tests nearly all semiconductors, as did its predecessor, the DCA55. They look very similar. They do a similar job. One big difference, and I'll get to that in a minute. DCA75, very handy for somebody who matches power components, for instance, audio files, doing electronic circuit design work with semiconductors. DCA75 make your job a lot easier, a lot quicker. We offer it here at Anatech Corporation, anatechcorp.com. So, John, JB, you say that these both test semiconductors. What's the difference? The big difference is DCA75 connects to your PC. With that connection and the software that comes with the DCA75, you can do a lot of data manipulation, data analysis, graphing, curve tracing, that sort of thing, all in this little gadget. Let me show you how we do that. Okay, let's see what DCA75 can do. Look at some of the cool things. Pay no attention to Chewbacca in the background there. That's my doggie. That's how she talks. I have here 4 pieces of IRF740 power MOSFET, and I've labeled them 1, 2, 3, and 4 so we can tell the difference among them. I'm going to connect it up to the DCA75. This is number 1. Like I said before, you don't have to pay any attention to how you connect it. DCA75 will figure it out. Okay, now I'm going to zoom in here so you can see the screen better. We're going to launch the DCA application called DCA Pro. Quiet on the set. Click on, let me make this full screen so you can see it. DCA Pro 75 says it's an N-channel enhancement mode MOSFET. Gives you the pinouts. The colors correspond to the test lead colors. So you can see what they are. Gives you a schematic representation. Shows you the body diode that's in there. That's something important you want to remember is in there if you're doing any design work. Over here it gives you the basic characteristics of the device. And here's more detailed information about those characteristics. Now we get to the really cool part. Up here we can select graphs. Gives you the types of graphs you can get for each type of component that DCA75 can test. For the MOSFET, we can get drain current versus drain to source voltage, or we can get drain current versus gate to source voltage. Okay, let's pick one of them. See what we get. This is drain current versus drain to source voltage. Down here you can select the ranges of values that you want to see. Right now it's set for drain voltage to go from 0 volts to 12 volts, gate to source voltage to go from 3.3 volts to 3.4 volts. There'll be 51 points for each trace, and there'll be a total of 5 traces. You can change all of those ranges to specifically what you want. Let's start it off here. And here come the curves. This is the first one. 51 points for gate to source voltage of 3.300 volts. And the next one is 3.325 volts. And it'll give us 5 traces. This diagram down in the corner here shows you exactly how this test is being run, so you understand exactly what you're getting. Very important to do. And there's our 5 traces. Now, we can do a number of things with those 5 traces. First thing I'm going to do is I'm going to save it. This will save a text file of all of the characteristics of this device. And I actually had it in here once before, but we're going to overwrite this. This will be IRF740-1. Yeah, replace that. Okay, now I'm going to delete this curve. And I'm going to connect device number 2. Now anytime you change components you're going to test, even if you think you've got the test leads in exactly the same spot, go back to the beginning, retest it, just to make sure that everything is the way DCA75 expects it to be. Now this is number 2. I notice here that the range of VGS changed, so I'm going to change it back so we got exactly the same information that we had before, 3.3 to 3.4 volts, and let's run number 2. Similar looking curve. There's the third one. 2 more to go. The speed of this graphing depends upon the number of points that you put on each one and how many traces you want to see. More points, more traces, takes a little longer. Okay, there's number 2. Let's save this data just like we did before. Save data. Number 2. Overwrite the one that's up in there. Now, if you're in a situation where you want to try to match components, you're working with a power amplifier, some sort of maybe a switch mode power supply or some sort of power supply, anything that has 2 output devices in it and you want to match the characteristics of them, DCA75 can help you do that. Watch. This is number 2. I'll tell you what I'm going to do. I'm going to delete this. Okay, now I'm going to load data. Here's number 1 that we did just a few minutes ago. Now I'm going to load on top of that number 2. Now you can see the differences between those 2 devices. You look at the blue lines are both for number 2 VGS 3.4 volts, and down here VGS 3.4 volts for number 1. You can see there's a big difference between those 2. These 2 devices are not very well matched. Let's continue. We'll get some more. I'll delete these out. Connect number 3. Run the test. Okay. Back to run the curves, make sure these are the same. That changes to 3.4 again. Now we're going to run the curves for number 3. See what we get here. The doggies are laying on a sunspot now, so they're being quiet. Oh, I spoke too soon. That's the puppy. Okay, here's characteristic curves for device number 3. We're going to save it. Alright, now I'm going to leave that on the screen for now. I'm going to pull up device number 2. Load data, number 2. Let's see what we got. Well, that's a little closer match. You look at the top blue lines here, they're a lot closer together than they were between 1 and 2. So 2 and 3 are a better match than our 1 and 2. But you know what? Now that I look at these curves, I'm thinking that maybe 1 and 3 might be an even better match. Let's take a look. I'll delete all this. Now I'll call up device number 1 and device number 3. See what we get. Why, those aren't a good match at all. My memory failed me. That's why it's good to save the data. You can see these top 3 lines are all device number 3. Very, very different from device number 1. Let's keep going and see if we can get a better match yet. Delete these. I'm going to connect number 4. Yeah, delete those. First we test it. Make sure everything's the same here. I gotta change this up to 3.4 again. And this will be device number 4. Okay, now let's take a look. So let's see if we can find a good batch here. This is number 4 that's up on the screen. I don't know, let's take a look at number 2 was the really hot one. Whoa, look at that. There is a good match. Number 2 and number 4, I doubt that you'll get a better match than that. So there you are. You got it. Very useful characteristic, or capability, I should say, of DCA75. But there's more. Let me load one of these. It doesn't matter which one. I'll take number 4. In addition to matching with the characteristic curves, and you can do that with all the devices DCA75 can test, you can also do this. Copy the data. That's copying the data of that set of curves onto the clipboard. Then go to your favorite spreadsheet. I use Apache Open Office because it does a decent job, and it's free. Put that data into the spreadsheet. There it is. All of the data points of those curves for, I think that was number 4, are now in the spreadsheet, and I can do whatever sort of analysis, comparison, additional graphing, zero in on a particular area of interest. Whatever I want to do, I can do from here. Very, very powerful feature. So there you have it. DCA75. This little tester has all that capability built in. You get all that capability right out of the box. All you gotta do is turn it on and plug it in, and you're ready to go. www.anatechcorp.com, and you'll find it and all the other component analyzers that we offer here at Anatech Corporation. Have fun!